OpenAI put up a paper called Why Large Models Hallucinate. And it's one of the best reads since a long time when it comes to papers around hallucination. And the amazing thing about the paper, when you read it, you see how relevant training AI models is to our lives as humans. It appears as we reflected our learning journey as humans into these AI models. And fundamentally, hallucination is guessing. So when you put your kids into school, and the way we rank our kids, the way we do the marking for their tests, is in a certain way incentivizing them to actually guess. So for example, if you have a test out of 10 questions, 5 you know for a fact the answer and you know you're going to get these marks. Now you have other 5 questions that you either don't know at all or unsure. As humans, as we go through these tests over and over again, well, we get smarter in how we deal with these questions that we don't know or are not sure about. And what we end up doing is we end up actually guessing the answers for these 5 remaining questions, because we learn with time that there might be a reward for guessing those questions, which is statistically getting some of them right. After OpenAI boiled down the hallucination problem is the way we test and evaluate and teach those models to guess and incentivize them to guess. Now they are proposing we need to change the whole game in artificial intelligence. We actually need to train them differently and test them differently. And what they're proposing is a change that is beyond OpenAI itself, is something they're calling a socio-technological change, which requires both a technical change and a society agreement. And here they refer to the AI society. And that agreement is now we need to test our models differently. We need to train them differently. And hopefully that happens for kids in school. Maybe it's already happening. And what we need to do differently is as we test these models, as we evaluate them, we give them a treat or a reward when they get a question right. But if they, with high confidence, answer a question that they get wrong, we give them a really bad penalty. And if they just get it wrong, we give them a slighter penalty. And if the model says, I don't know, they don't get a plus or minus, so they get a 0. As you would assume with a child, with time, they will think twice before guessing. And if they make a guess, it will be a high certainty guess. And if they're not certain, they would either answer without giving high confidence that this is the right answer, so the recipient of their answer will tell that the model is not sure, or they will tell the user, I don't know.